guys should hopefully have some of this done. It should be in the same order. So this is the quizizz version of it, okay? So again, if you get that done before tomorrow morning and you get the video one done before tomorrow morning, that could be worth some extra credit towards the test, right? So you could possibly have a 2-question buffer between you on the test here. So that could be good, right? Because again, if we don't increase our test scores on this one, we will not replace the final exam on that last one where we all bombed it, okay? So you need to make sure that you get that done, okay? It's up to you guys. All right, so we're talking about completing the identity, all right? So something like this, what we're going to do is we're going to use our sine, cosine, sine stuff, okay? This whole thing is the u, and this whole thing is the v, okay? So what is the cosine pattern?
Cosine.
Sine, sine. See, there you go. Everybody can remember Robert doing that now, okay? All right, with cosine, do I keep the operational symbol or do I change it? Change it, and then we're going to plop in the u and the v. So u was a minus b, and v was a plus b, okay? And then u is a minus b, and v is a plus b. Okay, then from there, I'm looking at my answers here. What happened? Oh, I did it totally differently than I did here. Yeah, that's not what I was supposed to do. Let me try that again. Okay, we're going to do sine, cosine, sine twice, okay? So I'm going to go back to the drawing board. So we know so this is going to be the u, that's going to be the v, that's going to be the u, that's going to be the v, okay? We're going to want parentheses around this back part. All right, so I'm changing what I did before, sorry. So we got cosine, sine, sine. And this is just this first half. And then I plop in an A, plop in a B, plop in an A, plop in a B, and the sign should be opposite. Okay? Then I've got a big minus sign. And now we're going to do this back part here. So I'm going to do this part in the back. So I'm going to do cosine, sine, sine again. So cosine, sine, sine. And then what operational symbol would I use this time? Subtracting, because we swap it on a cosine, right? We change it. So A, B, A, B. What are we going to do with this negative sign here? Distribute it. So watch what happens, and I'm going to just kind of write over the top here. So this one becomes negative, and this one becomes positive. Okay. What's going to happen now? Are there any like terms that cancel maybe? Look at this and this. Aren't they the same? But what's different about them? Negative sign, so don't those cancel? And then isn't this one the same as this one? So what do we do? What do we do with the two ones in front? Combine them. What do we get? 2 sine A, sine B. Is that one of our choices? Sine A, sine B. It looks like the third choice, right? All right, are we good with number 1? If you don't have it in front of you, make sure you have your textbook open to the chart, right? Because we're going to need that chart, and I want to make sure you understand how to. You need to make sure you understand how to use it for the test. I will basically give you a photocopy of that chart. It will also have the half angle at the bottom on it. Okay. All right. This one is probably the hardest problem on the test. Okay. It looks pretty simple to begin with, right? But look at where you got to go. You got to go from cosine to the fourth to one of those answers. Okay. It gives you a clue. It says first power of cosine. That means you need to use the power reducing identities. Okay? So everybody find your power reducing right now in your chart. Make sure you're following along with that. Are the power reducing in the first column or the second column? Second column. Okay, so everybody's found your power reducing. I'm going to rewrite this. In order to use power reducing, I need to have cosine squared. So I'm going to rewrite this as cosine squared squared. Right, that's how I would take apart a fourth power. All right, so what do I get to put in for the cosine squared part? Cosine of what? 2x over 2. All right, so I need to square the top and square the bottom. When I square the 2, what do I get? 4, right? So I'm going to take that, but it's in the denominator 4, right? So I'm going to take that and I'm going to bring it outside as a 1/4. So plus cosine 2x squared. Now cosine 2x squared is the same as saying I need to FOIL this thing, right? So really what I'm going to do is that. I'm going to get rid of my squared on there. Really what I'm going to do is FOIL this guy out. Okay, and then there's an algebra trick at the very end we got to deal with. Okay? All right, so what's 1 times 1? 1. Okay, 1 times cosine 2x. Cosine 2x, how many of those am I going to have? 2. All right, and then cosine 2x times cosine 2x is cosine squared 2x. All right, have I reduced it to the first power of cosine? No, there's still a power of 2 of cosine in there, so now I need to replace that. So this is where this one gets kind of ugly. I'm going to move it up to the top here. So we've got 1/4 times 1 plus 2 cosine 2x. All right, go back to the power reducing again. What do I get to put in there for the power reducing for cosine again? 2x over, okay, now it's a cosine 2x. What is in there right now for the u part? 2x, right? So I'm supposed to put 2 times 2x. What's 2 times 2x? 4x. So I'm going to pop a 4x in there. All right, I'm going to rewrite what I have. So I've got 1/4 times 1 plus 2 cosine 2x. I'm going to rewrite that as 2 fractions. So 1/2 plus 1/2 cosine 4x. I could rewrite this as 2 halves, couldn't I? So couldn't I combine this 2 halves with that 1/2? What's that? It's 3/2, good. All right, and then we've got cosine 2x. I'm leaving the 2 off for just a second. Cosine 4x. I want you to look at your answers. What do you notice we do not have in this second half? That there's no fractions, right? So I have to get rid of that fraction. So watch, this is the tricky algebra at the end, because you've got the answer right here. Okay, you've got it if you got to that point. I'm going to rewrite that as 4 halves, right? Because 2 is the same as 4 halves. I'm going to factor out a 1/2. So I have 1/2 times 1/4. So that means all of these 2's in the denominator are gone. And I get 3 plus 4 cosine 2x plus cosine 4x. What's 1/2 times 1/4? 1/8. That was one of our choices there now? So I think it's this one, isn't it? Is it B? Again, that's probably the hardest problem on the whole test. So that's why you're hopefully getting some extra credit, right? All right, we good with number 2? Okay. We are supposed to simplify this one. Again, it's going to be a sine, cosine, cosine, sine, cosine, cosine, sine, sine problem. Okay? So what's the pattern for sine? Sine, cosine, cosine, sine. Okay, what do I keep the operational symbol or change it? I get to keep it, and then I plop in the pi and the x and the pi and the x. Okay, so here's where unit circle comes in. I know those are my coordinates over there. What's the sine of pi? It's 0, isn't it? All right. And what's the cosine of pi? -1 sine x. Okay, double negative is going to go what? Positive. So this wipes out, and we've just got sine x, right? Yes, Ivan.
Where did you get 0 cosine?
I didn't. Where did I get that? Looked for the sine of pi, which on my unit circle is 0.
Okay.
Okay. I evaluated same thing with the cosine of pi. It was -1, right, from my unit circle. All right. Any other questions on 3? All right. Number 4 is where my big screw up was on the problem. Okay. So it was supposed to have been 5 pi over 6 plus pi over 4. So fix that in yours. Okay, and we'll do the whole thing, and it should come out with one of those answers now. Hopefully. No, my pen is not going to work today. Let me get this thing reset. Alright, now it's working. Okay, so let's take a look at it. I have to do my sum and difference formula. So for tangent, what do we know about the operational symbol in the numerator? Do we keep it or change it? Keep it, and then we do 1 minus and we do the change it in the bottom, right? And it's a tangent plus a tangent and a tangent times a tangent. And then we plop in the 5 pi over 6 and the pi over 4 and the 5 pi over 6 and the pi over 4. All right, now you're using your unit circle. So I want everybody to go to your unit circle. Okay, 5 pi over 6 is this one here. What are the coordinates right there? Don't give me the tangent, give me the coordinates. What are we getting, guys? For 5 pi over 6, what are the coordinates? Good, and what's the other one? 1/2. Okay, so I've got to do the sine over the cosine, right? So it'd be 1/2 over negative square root of 3 over 2. So what happens with those 2's? The 2's cancel out. So you got -1 over square root of 3, which if I rationalize that, I get negative square root of 3 over 3. So negative square root of 3 over 3. And that's going to go in 2 places. And then our favorite, what's the tangent of pi over 4? 1. Good. All right, I probably want to turn these both into 3's over 3's, temporarily at least. What's negative? So again, I've just got -3 square root of, there's negative square root of 3 plus 3 over 3. And the double negative is going to go what? Positive. So we've got 3 plus square root of 3 over 3. What happens with what's our shortcut on these denominators here? They cancel. So we've got negative square root of 3 plus 3 over 3 plus square root of 3. And it looks like the first one, right? Now the answers match. What? What formula? It's the sum and difference formula. So it's with the sine, cosine, cosine, sine. I think it's on the left side, isn't it? Sum and difference, is it on the left?
Oh,
Do you see it's at the bottom on the left? And so do you see the tangent formula there? Yeah. All right, everybody good with that one? Okay. It looks like a sine, cosine, cosine, sine again. Okay. It gives us the sine, it gives us the cosine, it tells us they're both in quadrant 2. This is the thing where I have to draw the triangles. Okay, so I'm going to draw my sine U triangle. So I'm going to draw my U triangle and my V triangle. I'm going to fill out the triangles first before I do anything else. So what is sine in SOHCAHTOA world? Opposite of our hypotenuse. So 4 and 5. What would my other side be? 3. Good. Okay. And then cosine is what in SOHCAHTOA world? Adjacent over hypotenuse. So -12 and 13. What's my other leg? Now, in quadrant 2, we know that sine is positive. So the sine leg goes positive, but what should I have put on this cosine leg? I should have put a negative there. Okay. All right. So now we should be able to do it. So what's your cosine pattern? Sine, sine. Okay. And then do you keep the sine, operational sign, or do you change it? Change it to minus, and then we're going to do UV, UV. Basically, you wrote the instructions out for yourself, right? You're saying, okay, now I know what I need to plug in. So what is the cosine of the U triangle? Negative 3 over 5. Good. What about the cosine of the V triangle? Perfect. Okay, and then the sine of the U triangle? 4 over 5. They gave that to us, right? And then I've got to read the sine of the V triangle. So what's the sine of the V triangle? 5 over 13. All right, and then what's your denominator going to be? 65. You can have a calculator tomorrow. I don't care. It's not going to help you a whole lot other than basic arithmetic. Okay? All right, what is negative 3 times negative 12? Positive or negative 36? Positive 36. And then we've got minus, what's 4 times 5? 20. It's okay. All right, 36 minus 20 is 16 over 65. All right, we good with 5? Okay. Number 6 says, it actually explicitly says, which formula are we supposed to use here? Double angle, okay? So you need to go find the double angle formulas. It wants us to find the double angle for what? Sine. So I'm going to do sine of 2u. All right. Oh, it gave me the tangent, right? So I need to figure that out with the triangle. So tangent of u. Tangent is what in SOHCAHTOA world? Opposite over adjacent. So it says 4, 3, and then what would my hypotenuse be? 5. But one of them has to be negative. Which quadrant is this talking about when we're talking about between 3 pi over 2 and 2 pi? 3. So which one is negative? Sorry, 4, not 3. Which one is negative, the sine or the cosine in quadrant 4? Sine. So the negative has to go on the 4 leg, not the 3 leg. All right. So looking at your double angle formula, what's the double angle formula for sine of 2u? Just read me the formula. Good. 2 sine u, cosine u. All right, so I've got to find the sine of that triangle. What's the sine of this triangle? I heard negative 4 over 5. Opposite over hypotenuse. What is the cosine of that triangle? 3 over 5. Excellent. All right, so we've got 25 on the bottom. What do we get across the top? Negative 24, so we're looking like the last choice there. All right, we good with 6? All right, let's look at, again, what formula do they explicitly tell you to use? Double angle. And you notice how these are kind of in a nice order. We had all this, they're not going to be like that tomorrow. It's going to be all scrambled all over the place. Okay? So, we're going to use the double angle formula to rewrite the given expression. So what do I probably need to do first? What do you think? Is there a greatest common factor there? Yeah, what are we going to take out? 5. What's left behind? 2 sine squared x. Okay, now I want you to go look at all your double angle formulas. Look at the right side of the equal sign. What can I replace that's on the left side of the equal sign with 1 minus 2 sine squared x? Good. Done. 2 lines. Don't get that one wrong. Okay? That one's pretty easy, right? Don't get it wrong. It's literally pulling out a 5. Everybody got it? Okay. All right. This one here, it says we're supposed to use a single power of cosine. So what does that mean I'm going to use? What identities? Power reducing. Good job. Okay. So I'm gonna go and look at the u though. We've got a weird u in there. It's not just an alpha, right? It's a 4 alpha. So I'm gonna pull that 6 out front. And I'm going to put the -1 in the back. I've got to do a power reducing in the middle. So what do I replace cosine squared with? Look at your identities. 1 plus cosine of 2u over 2. What are we plopping in the u spot? 4 alpha. Okay, let's do some simplifying. How many times does 2 go into 6? 3. And then we've got 2 times 4 is what? 8. So we've got 8. Sorry, cosine. Erase. Alright, cosine of 8 alpha minus 1. Alright, do I really need those parentheses? Oh, yes, I do. What do I have to do with this 3 first? I think I might have a typo in these answers, too. 3 plus 3 cosine 8 alpha minus 1. Now what do I do with this 3 and this minus 1? Subtracted. So we should have 2 plus 3 cosine 8 alpha. What's wrong with my answers? Yeah, it's pretty obvious typo, right? They should all have a 3 right there. Okay. So, but other than that, let's see. If I had that 3 right there, D would be my last one would be the correct answer choice, right? You had to distribute though and get the two like terms combined. Okay. All right, we good with 8?
Why do you give us such long problems?
They're not that long. I can give you ones that were more like the homework that were way worse. Okay, because I can change it. I haven't finalized the test yet. So, or I can make it look like this. Okay, sounds good. All right. They gave us the tangent. They want us to find exact values using cosine. What kind of an identity is this when you divide by 2? That's the half angle. Okay. So we're going to have to look up our half angle here in a minute. I'm going to first of all get this triangle dealt with. So if that's the tangent, in SOHCAHTOA world, what's the tangent? Opposite over adjacent. They didn't tell us what triangle or what quadrant, but let's assume it's quadrant 1 since it was positive. What would go on this leg here? Good. Okay, half angle. So I know I start with plus minus square root of. Anybody look it up? What is it for cosine? So 1 plus, in our case, cosine theta over 2. Okay, look at that triangle. What's the cosine of theta? Five over 13. Okay, it looks like then I want to turn the 1 into 13 over 13, right? What's 5 plus 13? 18 over 13, and then I'm going to flip and multiply the denominator, right? So I'd make it 1/2. Let's see, 2 goes into 18 how many times? 9. So now I'm down to the square root of 9 over 13. What's the square root of 9? 3 over the square root of 13. Likely they would probably rationalize their answer if we had multiple choice, right? Wow, what happened there? Something bad. Oh, I see what I did wrong. Let's see, cosine would have been, let me make sure I've got my tangent right, opposite over adjacent. Cosine would have been 5 over 13. Yeah, I put 12 over 13 in here when I did my answer key, so that's why there's no correct answer. Which one's closest? This one here, right? Yeah. Miss Dudley's checking the test, so hopefully they'll be correct answers. Okay. All right. That was her job today, was to correct the test, unless I need to change it right now, because Ivan wants it to make it harder. Okay. Okay. We good with 9? Alright, let's look at number 10. Alright. These are some of the easier ones, right? Be careful and make sure you're in the right spot on your chart. Everybody look for product to sum right now. Okay, so looking for product to sum. The 8 is just going to float out in front for now. Okay? I'm going to leave the 8 out front. How does product to sum start? 1/2. I've got to go cosine times cosine. So what are my two pieces of trig that I put in there? And don't assume, right? Because it's a little bit different on both of them. What operation is supposed to go in between them? It's supposed to be a positive, and then inside this one it's a negative, and inside this one it's a positive. And then we're going to plop in pi over 6 and pi over 6 into both spots. All right. What can I do with this 1/2 and the 8? Cancel. Can I bring that down to 4? All right, and then this is going to be cosine of what? What's pi over 6 minus pi over 6? 0. And then pi over 6 plus pi over 6 is 2 pi over 6, which reduces to pi over 3. So isn't it this choice right here? All right, we good with 10? All right, looking at 11. So again, we are using product to sum. Okay, we've got cosine and cosine again. Oh, that's interesting. We did cosine and cosine again. All right, so we're going to have, what does it start with? 1/2. And then what do we do for what are our trig pieces for cosine? Cosine and cosine. Okay, and what operational symbol do I put in between? Plus. And in this first set of parentheses, what's the operation? Minus. And the second set, I put a plus. And then we plop in our two angles, right? So 2 theta, 4 theta. 2 theta, 4 theta. All right. What's 2 theta minus 4 theta? Negative 2 theta, and 2 theta plus 4 theta is 6 theta. But you'll notice we don't have one with a negative 2 theta up there, right? Because then we use the even and odd identities. What do we know about cosine when it's negative? Do we bring the negative out front, or does it disappear? It disappears. So 1/2 times the cosine of 2 theta plus the cosine of 6 theta. All right, so let's see, 2 theta, 6 theta plus, it looks like the second choice, right, B? Why do some of the answers have 2 out front? Yeah, the other one starts with 2, right? We're trying to get you to pick the wrong one. All right, we good with 11? The sum to product starts with a 2 out front instead of a 1/2 out front. We're trying to get you to confuse it. Okay. All right. We're switching, right? What does it say we have to look for? Sum to product. Okay. So I'm going to go to the sum to product identities. What do sum to product identities start with? 2. Okay. So I'm starting with a 2. And we've got, what, for cosine plus cosine, what does it turn into? Cosine times cosine. All right, we divide them all by what? 2. And then what's the first operational sign? Plus, then negative, and then I plot my angles in there. So 8 theta and 4 theta, and 8 theta and 4 theta. All right, what's 8 theta plus 4 theta? 12 theta over 2, and 8 theta minus 4 theta. 4 theta over 2. All right, what's 12 theta divided by 2? It better be. Look at all your answers. They all have 6 thetas. What about the 4 theta divided by 2? 2 theta, and again, it better be. It's in every answer choice. So it looks like the first one, right? right, we good with 12?
Yeah.
All right. We're supposed to use the sum to product formulas to rewrite the given expression. So we're going to sum to product again. All right. So we're looking at a sine plus a sine. What do all the formulas start with? 2. Okay, and sine plus a sine turns into what? Sine times cosine. We divide them all by 2. What operation goes in the first one? Plus, and in the second one? And then we've got 4x and 2x. Sorry, what am I doing? Writing the answers in there. It should be 6x, 2x and 6x, right? Oops. Going the wrong way now. All right. So 2x and 6x and 2x and 6x. All right, what's 6 plus 2? 8x over 2. And then cosine. Oh, it's 2x minus 6x. Negative 4x. And then 8x over 2x is going to be what? 4x. And cosine of what? Negative 2x. Again, we have that property again. So with the cosine, do I bring the negative out front, or does it disappear? Disappears. So 2 sine 4x cosine 2x. 2 sine 4x cosine. So it looks like this one here. All right, 2 more, right? Okay, notice this one. Okay, I wanted to show you the difference between this and what we're doing here. Do you see how this one, when it says use sum to product, that the plus sign is between 2 pieces of trig? Okay? Do you see how the plus sign, don't worry about inside there. This is where we use the sine, cosine, cosine, sine. Okay, and we're going to do it how many times this time? Twice. So it's just like the first problem. It's on there. It's on the test twice, the same problem. You better know how to do it, right? Okay, so what's your cosine pattern? Cosine, cosine, sine, sine, right? So this one, the first one hopefully had a different symbol in the beginning. So cosine, cosine, sine, sine. All right, what operational symbol do I do with cosine? Do I keep it or change it? Change it. So I'm going to change it to minus, and I'm going to plop in A and B and A and B. So if both of these ones on the study guide were cosines, what are they likely going to be on the test? Probably sines, okay? All right, we're going to put a plus sign down, and I'm going to do that cosine pattern again. Cosine, cosine, sine, sine. And what operational symbol is going to go in between the two this time? Plus. We change it to the opposite. And then we're going to plop in the A and the B, and the A and the B. What do we notice? What are we going to cancel? Yep, those are gone. And then what do we notice about these? They're the same. We combine them together. What do we get? Cosine B. It's a 2-line problem. Again, it's on the test twice. We should probably know how to do it. Okay? Remember, 15 questions means all the problems are worth, well, I think we dropped the test to 800 points, so they're all worth 50 still. Okay? Alright, we good with 14? Only got one more. Alright, your key to this one, and I think I tried changing the instructions, is you need to use factoring. Okay? So, start factoring it and it falls out really fast. You could probably mess with your power reducing, but let's not do that because it's a pain. Okay? Alright, so if I factor it, it's what kind of factoring? Difference of squares. Good. So we're going to have we know we got a plus and a minus in there. What's the square root of sine to the 4th? Sine squared is going to go in the front. And then what's the square root of cosine to the 4th? Cosine squared. All right. So Look up at the windows. What's sine squared plus cosine squared equal to? 1. Okay, now I want you to go and I want you to look at your double angle identities. So look at the double angle. You might want to write yourself a note that this is a double angle. Does this look exactly like the cosine one? Are you sure it looks exactly like the cosine one? What does the cosine one say? Cosine squared minus... Could I turn it into something that looks like that? Couldn't I just take out a negative 1? So I know that that's a 1. I'm going to take out a negative 1. So what's going to be the sine on sine squared then? Negative sine squared. And then what's going to be the sine on cosine squared? Positive cosine squared. Now what do I get to replace that with?
1.
No, look at cosine to u. In this case, my u is x. So it would be the second one here with a negative in front. Now that one might not be as tricky on the test. It might come out nicer on the test. You might not have to factor out the negative, but I don't remember. Okay? I couldn't make it the exact test question. So, all right, that's it. We are going to collect notes. I need you guys to go back and look. What was the last front page that I didn't collect notes on?
All the way back.
I know, it's been a while. And we probably need to get it marked, right? I didn't do it on the I think I wasn't here or something. Yeah. Sorry. So I'm gonna grade all 3 of them, but I'm only gonna give you 1 grade for it. Okay. So what page are we starting on? Everybody found it?
Since you missed 2, you shouldn't even do
I think it's 191.
191. Everybody look at page 191. Okay. I'll get you a piece of tape tomorrow. We don't have it marked, correct? Is that right? We don't have it marked? Okay, so let's go to page 191. As long as we all agree on the same starting page. Okay. Yeah, but you want to go, did I grade that one? It's 170, I didn't do 170. Look at 170. Looks like we might have already marked it. I haven't checked 170. Do we all have a piece of tape at 170? Yeah. Okay, so I'm going to start from page 170. Okay? So for the last few minutes right now, you could be looking that over and making sure that you've got it all updated. Let's also try to get our papers numbered here. Okay? So give me a minute. I will get that set up and passed out because I know we don't have even and odd type right now, but let's see if we can fix that. Okay? Yeah. Yeah. Anybody else need a piece of tape for page 170 because they don't have it? We may have marked it and then I didn't collect it that day or something. I know I was gone on 1 or 2 of the tests. Anybody else need a piece of tape? Okay. So this is page 170. Alright, let me fold these. Yes. We skipped the angle of elevation and angle of depression notes. Okay?